Play mode.
Good morning, everyone, or perhaps good afternoon. Thank you very much for joining us for today's webinar. Today, we're super excited to be featuring one of our customers, and that's Oakland Unified School District. And we'll be sharing with you how they've enabled high-density testing, some of the challenges that they've faced, and how they've addressed them, and used the Meraki solution to do that. And we'll also be able to show you their actual deployment right here during the presentation, and walk you through some of the details of that. So thank you very much for taking some time out of your busy schedule to share it with us. My name is Pablo Estrada. I'm also joined by my colleague Simon. We're both very excited that you're here today, and we have some great content coming up in the next hour or so. We'll kick it off with a quick introduction to the Meraki product line and also a little bit into cloud networking so you have a better understanding of how it works in the background. But of course, the majority of the time we'll spend focused on the case study featuring Oakland Unified School District. We'll go through some of the challenges that they've been facing and what they've done to address those, as well as a live demo. And we'll wrap it up with a quick look at the Meraki product line, as well as having some time for Q&A. Now, if you do have any questions throughout the presentation, whether it's about the Meraki solution, the Oakland USD implementation, those challenges that they've faced, and so on, please go ahead and enter those questions into the questions area of GoToWebinar. So Simon and I will be monitoring the Q&A and answering as we go along. And then if you do have further questions or something you'd like to see more in depth, and if we do have time, we may be able to go ahead and discuss that a little bit further in the Q&A portion at the end. Before we start off with the first item here, there's one item that's very exciting to share with you, and that's that we are offering a free access point to the qualified IT professionals that are here with us today. This is a Meraki 802.11n access point, similar to the ones that you see there on the screen. Comes with a 3-year cloud management license, and it's absolutely yours to keep. You can take it home. You can get it up and running in about 10 minutes or so. It's very, very straightforward. And that way you'll have the full experience of the Meraki hardware and of course the Meraki dashboard right in your own hands. Of course, we want to make sure we send that access point to the right address. So we ask that you please call us to confirm your shipping information. And if you can't quite remember who you're supposed to call, just go ahead and look in your email for a reminder that was sent before the start of this webinar, and there you'll find the contact information for your Meraki rep. Okay, so let's go ahead and start off with a quick introduction to Cisco Meraki. Cisco Meraki is a completely cloud-managed networking solution that includes Wi-Fi, switching, security, and MDM, all of which are centrally managed over the web through the Meraki dashboard. And that entire solution is designed and built by the Cisco Meraki team from the ground up for cloud management. What that really means is that the hardware, the software, the cloud services are all very tightly integrated so that the network administrator, the user, has a very feature-rich and easy-to-use experience that works right out of the box. We are the leaders in cloud-managed networking. There are tens of thousands of customers across all industries that have deployed the Meraki solution. We've recently been seeing tremendous growth, in fact, over 100% annual growth. And we've been recognized by not only those customers, but also by outside organizations since we've been operating in the cloud since 2006. Folks like CRN, InfoWorld, and Gartner with their Magic Quadrant for wired and wireless LAN infrastructure. Now, those customers are spread across all kinds of industries, as I mentioned. Actually, education, and in particular K through 12, has been one of our strongest markets. And thousands of K through 12 campuses have, in fact, trusted Meraki for their networking needs. Of course, today we're going to feature Oakland Unified School District, but here you see just a few logos of the other schools and school districts that have deployed the Meraki solution. And in fact, many of these that you see here, we actually feature on our website as well. If you go to meraki.cisco.com, click on the link to see the deployment stories, you can actually filter those customers out and look just at the K through 12 customers, and you'll be able to read more details about each of those schools' deployments, their challenges, and what they've been able to do with the Meraki solution. Also, if there are any here or on the website that you see that are particularly interesting and perhaps you want to talk to someone at that district, do let us know, and we'd be very happy to set up a reference call for you. Now, to give you a little bit of background into cloud networking and architecture, it's worthwhile just to go over at a high level how the technology works, and then when we go into the demo, you'll have a better understanding of what's going on behind the scenes and the technology that really powers it and makes it all work. This is an overview of the Meraki solution, including the cloud architecture and how it would fit into a school or district environment. It starts off with high-capacity hardware that's deployed on-site. That is a wireless access point, could also be a switch or perhaps a security appliance. And those devices are connected to the Meraki cloud. They do that through a thin and secure link. And over that, over that link, they exchange management and configuration data. And that's true if you have a single, perhaps high school, or if you have a district of many schools, including high school, middle school, elementary schools, perhaps some district offices, and so on. And at all those locations, the network infrastructure automatically connects to the cloud, and it's that system that gives the IT department the centralized visibility and control that's available through the Meraki dashboard. Now, we've designed this architecture in a particular way so that it is very reliable, scalable, and secure. So I'll just talk a little bit about each of those, and it's worthwhile pointing out a few of the aspects that we've designed into the system that inherently makes it secure, scalable, and reliable. And as we've evolved the system and developed it over the past several years, we've really been looking at ways that we can bring the benefits of the cloud to K-12 networks. So I'm sure all of you are familiar with the cloud to some extent. Perhaps many of you actually are using some type of cloud apps or tools in your schools already. And some of those benefits that we see already with other solutions, things like ease of use, scalability, being always up to date, and so on, we've brought those to networking now. Now, the aspects that I want to point out about the design of this architecture, this is just kind of a zoomed-in view of what we were talking about in the previous slide. The first is that no user traffic passes through the cloud. So the Meraki devices, those APs and switches and so on, they connect to the Meraki cloud just to exchange management and configuration data and statistical data and so on. The students' traffic, the teachers and staff traffic, those do not go through the Meraki cloud. We've also built in some pretty robust security tools that enable the deployment to be deployed in very secure environments. Things like automatic firmware and security updates, daily vulnerability testing and third-party security audits, two-factor authentication, role-based administration, and so on. All of those together make for a very secure solution that is applicable for, of course, schools and also very secure environments. Another aspect of the design of the system that I'd like to point out is that the network still continues to work even if the connection to the cloud is interrupted. Now, a few notes on reliability. In the previous slide, we didn't show the details, but we do have a highly available cloud with multiple data centers. They have built-in redundancy, data replication, automated backups, and so on. We also back up those services with a very high uptime SLA, 4 nines of uptime. But in the event that the connection to the cloud, that connection between the network infrastructure and the Meraki cloud is interrupted, then the local network will still continue to work. So students will still be able to get on the Wi-Fi, teachers will still be able to use the network, they'll still be able to use printers, file servers, and so on. If they're connected to a district office or similar internal resource, they'll still be able to access those. It would just be the ability to make a configuration change on the network or use some of the real-time tools that we'll be showing you a little bit later on that would, in this case, not be available while that connection is interrupted. And finally, one note about scalability, and maybe it'll be worthwhile to just briefly go over how the Meraki solution is deployed to begin with. And this will actually help us understand how the system is very, very scalable. When a Meraki device, say an access point, is initially deployed, it will be installed perhaps on the wall, maybe mounted in the ceiling, and then connected to the local infrastructure like a switch and turned on. At that time, the Meraki device will automatically connect to the Meraki cloud. It'll identify itself by serial number, and the cloud will know that that access point or switch or security appliance belongs to you. It'll send the appropriate configuration, apply the policies that you've defined in the dashboard right down to that device, and then you'll be able to monitor it and see it go live in the dashboard and check the configuration, change it if you need to, or simply monitor and see that folks are connecting and it's actually being used. And that is true if you have one device or if you have hundreds or thousands of access points or switches. All of them will be deployed in the same way, in other words, with zero touch required. And it makes it very, very scalable and allows you to add more network capacity on the wireless side or on the switching side, and more sites. If you have a new school, for example, or if you're bringing up perhaps a very remote school, if you have a large distributed district, then you can even send out that network infrastructure to the location. Perhaps you have someone from your staff who's not the networking expert that can simply install it, maybe mount it in the rack, connect it, and turn it on. And then you can just let the cloud automatically provision the devices, apply the appropriate policies, and you can do all of that from a central location just by using the Meraki dashboard. Another aspect of the solution, because this is a software as a service type solution where we have a cloud-based dashboard that is continuously updated to have new features, is that we've been working with many, many schools. As I mentioned, it's one of our strongest markets, and have definitely seen many of the challenges that schools and administrators are facing. Things like limited IT budgets, very high density device usage, rich media applications. These are very common in today's day with K through 12 IT departments and school environments. And so we've built in features that enable those departments to meet those challenges and really address the needs of the K through 12 market in general. So for example, the zero touch device provisioning that we just talked about for the initial installation, as we'll see in the dashboard demo a little bit later on, the system itself is very, very easy to use, so you don't need additional training or additional staff just to run the network. We also have built-in tools to help you with that high capacity and high density need, and to control the applications that are in your environment, to prioritize those important ones, some of those that are used for the learning environment or in the classroom, and also to throttle or even block ones that might be recreational or just consuming too much bandwidth. So that's an introduction to the Meraki solution. I just wanted to give you an overview of the technology and how it is that we're bringing the benefits of the cloud to K through 12 networks. And now I'm really excited to focus on the high density Wi-Fi at Oakland Unified School District. And Oakland Unified School District has been very exciting to work with because they have some pretty innovative programs, and they did have some networking challenges that they needed to address. And we've been very fortunate to be able to work with them to meet those challenges. To give you a little bit of background about Oakland USD, they're located in Northern California. They have 120 K through 12 schools and child development centers, and across those, together that's about 37,000 students and 3,500 staff and teachers. The technology staff consists of 34 members of the IT team, led by John Krull, the Chief Technology Officer. He started with Oakland USD back in August of last year. And of those 34 members, 5 are dedicated to the network. So it's not a huge networking staff that's part of the IT department. And they are participating in the Common Core initiative. This is a state-mandated online learning and testing initiative. And the first round of district-wide online testing happened in April 2014, so just very recently, in fact. Now, to go over some of the requirements, the general requirements for Common Core, there are a few things that we need to ensure to enable that testing, and of course this becomes more crucial as we support not just one school, but say a whole district with hundreds of locations. Of course, the devices and the operating systems must be ready for every student tester, including things like using approved OSs on the testing devices, having single app mode ready for the testing functions. The infrastructure has to be there to support the connectivity of those devices. So definitely means reliable Wi-Fi coverage for the testing environments, and some capacity needs based on, in terms of bandwidth, based on the number of students that we need to enable and connect. On-site logistics, of course, are affected by this because if we have Wi-Fi infrastructure that needs to be reliable, we need to have the Ethernet networking and wiring to support that in terms of the power supplies, the space, the cabling, the device storage, the bandwidth, the capacity, the port availability, and so on. And of course, somebody has to run all of this, make sure it is configured and deployed and maintained over time. So staff has to be trained to administer the testing applications, and on the infrastructure side to be able to troubleshoot any issues, to make sure that the devices and the infrastructure are running reliably, to solve and fix any issues, and be able to do that very, very quickly, of course. Now, Oakland USD was facing some challenges at the end of last year, and we have, you'll see there, the quote from John Kroll, their CTO, they needed to have equitable, supportable, and standardized solution across all their distributed sites. As of August of last year, about a third of the schools needed some kind of network upgrade because they had at the time an ad hoc network for Wi-Fi, so they would allow the occasional roaming teacher to connect. And they had about 10,000 existing computers, but of course with varying ages and models, but a pretty broad mix of devices. They did get federal E-rate funding to upgrade those, and in fact were able to secure 10,000 Chromebooks on carts. We'll look at those a little bit later for testing and learning. And they've installed a Meraki 802.11ac access point mounted on each cart. It's a very innovative solution in terms of how to support those devices with reliable Wi-Fi infrastructure. And those Meraki APs, of course, are cloud managed. They provide that reliable, standardized Wi-Fi that's going to be that has been used for testing, and the IT staff has a visibility and control into those Wi-Fi APs, or in other words, into those carts. And having that standardization really reduces the complexity for the IT staff and increases their control, and of course makes it so that all those sites do have that equitable solution that John mentioned in that quote. Oakland USD chose the MR34 because it's designed for next generation networks, and it's in particular for more devices and high throughput applications. If we just look at 802.11n as it compares to the new standard 802.11ac, 802.11n is very familiar to everyone. It's supported by nearly all devices. It's a few years old now. It does support up to 450 megabits per second. On the other hand, 802.11ac actually has not only fully backwards compatible operation with the legacy standards like 11n and even older standards, but it's up to 3 times faster than 802.11n. And in particular, the MR34 has some tools such as a dedicated security radio that not only has security tools like intrusion detection and prevention, but also automated RF optimization and channel planning. And together, those enable the school to support the current density of devices, support the future needs and expansion of devices, and expansion of high density, high throughput applications that are going to be used by the school and by all those Chromebooks in the future. So it really future-proofs the Oakland USD's network needs. Now to start, Oakland Unified started with a pilot program. They placed Meraki MR34s in classrooms at one high school, and they decided to test over several weeks. They received great feedback from that, and after completing their evaluation, they deployed 300 Meraki MR34s throughout the district, and as we mentioned earlier, one AP is installed in each of the Chromebook carts. And they were able to do that initial access point configuration right in the dashboard, and then when those access points were installed in the cart and the cart was powered on and connected, then that configuration that they had already defined in the dashboard was pushed out to each of those APs. And in the future, they're planning to install a Meraki AP in every classroom and workspace and have separate networks for daily classroom activity, for research, for collaboration and applications. Of course, that is beyond the testing application that was the focus in April of this year. In terms of segmenting Common Core devices, we've worked with a lot of schools to share the best practices that we've seen in education environments and how to do that from a networking perspective. And one of the key aspects of really laying the foundation for a secure implementation is the segmentation of the network. And in Oakland USD's case, they have a Chromebook cart SSID. These are for the Common Core devices, and it's the dedicated SSID using Meraki DHCP. What that means is that the Meraki access point that's deployed in the cart is actually serving as the DHCP server for those Chromebook devices. So it makes it very, very scalable and easy to manage, because essentially the IT staff doesn't have to worry about managing the IP ranges for those 10,000 devices. It's all handled right at the cart, so to speak. And then authentication is still done through 802.1x, so we have user identity and identification still supported in that. In terms of the classroom and general workspace SSIDs, that's used for day-to-day learning activities. We have students logging on through Google Directory, teachers using Active Directory. So again, there we have secure, traceable authentication. Oakland USD also had an existing Cisco architecture, and you can see a little bit of that in the diagram on the right. I'd just like to point out a few things and how they integrated the Meraki Wi-Fi solution that we've been talking about into that architecture. They do have a data center, and that houses district services, servers, security tools, storage, and so on. They have a redundant backup for that. That, of course, is supporting this very large district. And as you see in there, we can see some Catalyst switches, some Nexus switches, a WAN router there, and you can see similar devices in the redundant data center on the right side. And in the distributed sites, in other words, at the elementary, middle schools, high schools, and so on, they did connect back via a hub and spoke model to the data center via a metropolitan WAN. So that's a fairly common scenario that we see with public school districts. Each site has a main switch closet, and that connects to smaller switch closets as needed, and they standardized on Cisco Catalyst 3 which is in that case. And then the Meraki APs are connected via PoE ports. So all the Meraki APs can be powered using PoE. The dashboard, the Meraki dashboard, gives the IT staff visibility into the access point status, the connection, the traffic, the users and devices that are connecting, the applications, and of course, we can apply those configuration settings on a per SSID level, or if there needs to be a special case, maybe in one particular classroom in a given school, a particular access point can also be tweaked and tuned individually. Now, as we mentioned earlier, Oakland Unified School District has a lot of devices, and they needed to handle a very dense Wi-Fi environment. And thankfully, the Meraki solution allows them to use some built-in tools that automatically allow them to support the high-density environment. Things like automatic airtime fairness for equitable bandwidth distribution, seamless and fast roaming throughout the Wi-Fi environment for those carts or for those students and teachers that are moving around the campus. And for those very highly saturated environments, of course, this brings to mind the 2.4 gigahertz Wi-Fi band, then the Meraki APs have automatic RF optimization. I mentioned this is powered by the dedicated radio in the Meraki MR34, and that provides round-the-clock monitoring and optimization for best performance. And then in terms of the optional tools available to the IT staff, there are layer 7 tools that allow visibility and control to not only prioritize those important applications, for example, setting QoS policies to get the best multimedia experience in streaming, but also to throttle recreational applications, maybe some that are allowed by policy, but we just don't want to be consuming too much bandwidth, and also to block entirely those applications that are not allowed or just completely unwanted on the network. In terms of the network visibility and the control, the IT staff has centralized visibility into all the distributed locations, and the dashboard can identify things that might be happening in the rest of the network too, as indicated by, say, loss of connectivity to an access point or misconfigured DNS servers or things like that. And even though there is a relatively small staff, they do have role-based administration that they use to give read-only access to help desk technicians. And that way, the help desk techs can be that front line of support across all those schools, and they can use some of those built-in tools to see what's going on in the system and the environment. And then, of course, if they need to escalate that to the dedicated networking team, they can do that. And the frontline help desk and networking teams have visibility into the same aspects in terms of the read-only, and so they can actually share the tool without having to be in front of the same computer or the same piece of network infrastructure at the same time. In terms of security, I mentioned earlier that the dedicated radio in the MR34 also provides protection through intrusion detection and prevention. And this is very useful in education environments where, especially with the tech-savvy students that might be bringing in, say, Wi-Fi routers from home, maybe MiFi devices, the built-in WIDS-WIPS functionality in the Meraki wireless system identifies if perhaps a clever student is trying to disrupt the Wi-Fi. Sometimes they just want to have, in their eyes, just very personalized high-speed Wi-Fi access. And it'll not only identify them in terms of their presence, it'll also identify any potential threats or attacks that might be happening on the network, and optionally contain them if you choose to. You can do that on a case-by-case basis, or you can do that in an automated way, having the system do it whenever it detects certain keywords in rogue SSIDs that are detected. Now, in terms of Oakland Unified School District's particular results, they were able to complete their Common Core testing without issues, and they actually met with the California State Superintendent of Public Instruction, and as they reviewed the results of that, the focus was really on the effectiveness of the tests, not the technology or the network, which we think is great. That's fantastic. That is really how we can best help K through 12 schools. In other words, simplifying the IT staff's lives so that they can focus on really meeting the needs of the school, the students, and the teachers and the staff, not focusing so much on spending too much time managing or troubleshooting or maintaining the day-to-day network, but really meeting the objectives, in this case, the Common Core testing. Overall, the network infrastructure has improved and beyond just the testing aspect that happened in April, with increased Wi-Fi speeds, with improved security, and generally with robust and reliable Wi-Fi that provides support for high-density daily usage. You can see the quote there from John Kroll. I won't read it out to you, but you can see there that the focus was on really the success and the effectiveness of the testings, not about trouble with bandwidth or computers or slow speeds and so on. So a few things to keep in mind if you are moving into Common Core, and we have provided this checklist so you can just quickly run through them and see if your student devices are ready for Common Core. We do have tools, including a cloud-based MDM solution called Systems Manager that can ensure that the devices are used in the right way and have the right content on them. Of course, we need to look at the infrastructure to see if the Wi-Fi infrastructure can support the increase in the number of devices, and the staff isn't overburdened and is able to quickly troubleshoot issues, and if there's enough bandwidth dedicated to students, and if the bandwidth is being used for the right reasons. The Meraki dashboard has the tools to monitor and optimize and control that for each of the SSIDs that are used. So with that, before we go into the products, I'd like to actually go into the Oakland Unified School District network, and they've been very gracious in giving us permission to show and share their network with all of you. And so what I'll do is just log in to the Meraki dashboard and walk through just a few of the highlights of their deployment. And we'll start off with just an overview of their deployment and their footprint so we can see what they see on a day-to-day basis as they have this central IT staff that manages all the locations across the entire district at the same time. So we'll first start at this page, which is called the Organization Overview. And it's here that we can see at a glance what's happening in terms of all the networks that are monitored and managed by the Oakland USD IT staff. And in this view, we can see some icons on the Google Maps or pins, and those larger pins indicate collections of many networks. For example, here we have 3 networks in this pin. We have 13 networks in this other pin. Naturally, the different colors indicate the relative health of the networks. So in green, we have networks that are healthy. In red, we have networks that may need to pay attention to. We can even expand this out and have a look at a little bit more detail in terms of the usage, the clients, the number of devices, how many are online and how many are offline. For example, here we have the Chrome cart network. We'll look at that in just a moment. You'll see a lot of clients, over 2,000 clients, but currently most of the devices are offline. Now that is not unexpected due to the nature of these carts because they are portable and mobile and they can be and are disconnected from time to time. We can sort by any of these, for example, sorting by their usage or number of clients or number of devices and so on. We can also click into the map here and zoom in. We're going here into Oakland, and we can click in on any of these networks that we might want to further troubleshoot or look into. So why don't we have a look at this particular network. This is the Chrome cart AP network. And we'll start off with a look at the access points, just to give you an idea of what the infrastructure looks like and what's going on. And here we see 259 access points, and they've done a great job of labeling each of those APs by the site and by the cart number. And they've also decided to include the MAC address for convenience in that name. And we can see which ones are online right now. We see a handful that are not online. We can expand this out to look at all of them at the same time, or of course we can just go through the pages and pages. Now school's out for the summer, so some of these are expected to be offline. Some are online right now, and we can see, for example, which ones have been the most heavily used in terms of bandwidth, or perhaps in terms of number of clients, or we can have a look at which ones are connected right now and look into them. Let's in fact have a look at that and dive into one of these just to have a look at some of the tools that are available into, in this case, the particular cart. And here we have an MR34. This is the one installed on cart number 28 to site 210. And we'll see a few things about it right now. Of course, we have configuration and status information. In this case, we have LLDP information about its connectivity. We have a fast Ethernet connection. And here we have, of course, host name information about the device it's connected to. And we also see some RF information. It is a dual band access point supporting 802.11ac. And as you may know, 802.11ac works in the 5 gigahertz band. So we have some additional information about the 802.11ac RF configuration. In this case, it's using an 80 megahertz band with the primary channel being channel 44, but of course extending beyond that. Below we have some live tools that help us with monitoring and troubleshooting of the network. Currently we see the current clients that are connected. There's no single device connected to this particular access point right now, but we see there's some Ethernet traffic flowing. We can monitor the channel utilization across all the different channels. Not unexpectedly, it's the 2.4 gigahertz band that has much higher utilization than in the 5 gigahertz band. And there's some built-in troubleshooting tools. For example, if we want to use the ping tool, Naturally, ping is a very commonly used tool, but here we don't have to go on site. We don't have to bring up a terminal or command line to ping. All we do is click on that button and send ping packets to this access point. You'll see the latency on average is under 20 milliseconds. There's no loss. So this device, this cart, has a very healthy connection. We can also trace routes. We can check throughput. We can even blink the LEDs. So perhaps all the carts are in a given room, and we want to identify one particular access point. We can click here to blink the LEDs, and that'll help someone who's physically present actually find the cart and see where it is, if it needs to be, say, upgraded, something needs to be changed on the cart itself, and so on. And then we can even reboot the AP if we need to. And further below, we'll see some information into the connectivity, the utilization, and the access point usage. That's looking at the past 12 hours, but we can zoom out and look at, say, 2 days or a week's worth of information and see the traffic as it goes up and down. Looks like it died down just last week a little bit, and channel utilization has been fairly steady, a slight spike here around June 16th, but otherwise, I would say pretty healthy. We can, of course, see this information and use these troubleshooting tools for any of the access points, or if we want to go into some of the other networks that we have, for example, Emerson or Fruitvale or Glenview or Montclair, we can just click on any of those networks and we'll see the same information and the same tools for any of those locations. And that's really what enables that multi-site and centralized management. The ability to go into the dashboard, pull up any of these networks, and immediately be able to understand what's happening with the infrastructure, to monitor it, to troubleshoot it, to change the configuration, whatever we need to do. Another aspect I'd like to show you is the visibility that we have into the users, the devices, and the clients. And this is a look at that. And here we're looking at the past week's worth of information. Let's go ahead and zoom out to the past month where there was more activity. And you can see the peaks were actually fairly high here, over 100 megabits per second, often over 120 megabits per second in terms of usage on the network as we went through May and early June. And in total, in the last month, 7,600 plus devices connected to the network, and they pushed 3.42 terabytes of data. Now, if we want to, we can search for any device on the network here. Naturally, we can search by IP address or MAC address. That's not always the most handy information to obtain, so we've also integrated a search tool here that takes advantage of a technology we call client fingerprinting. And client fingerprinting allows us to search for things like iPads or maybe iPhones, see how many iPhones have connected, 421, or we can find a particular person, so perhaps we want to search for Carl, we can see Carl's devices, and client fingerprinting is working. It's integrated into the Meraki access points and working by identifying little bits of interesting network traffic that help it to and automatically allow it to profile and identify devices. So it's using things like DHCP requests, web browser user agents, NetBIOS and Bonjour traffic, and so on, and automatically building this list of clients and making it very, very searchable, very quick and easy to find a particular device. And then for any of these devices, we can go in and click on, let's just click on this one, happens to be an iPhone, and see what it's been doing, when it was last connected. If it was connected right now, we could see the details of the access point it's connected to. You'll see it was last online just around June 5th, and it was connected to an SSID called CB onboarding for Oakland USD. That's an onboarding SSID. It was connected to cart 136, site 335, and you'll see this was an Apple iPhone with just 2.4 gigahertz capability, so it's not the latest version of the iPhone. And we can see the activity over that past month, 15 gigabytes of traffic. If we look at the applications, we'll see, in fact, almost all of that was, almost 14 of those 15 gigabytes was going to iTunes. And that's very interesting because iTunes is generally considered recreational in this environment. This iPhone was holding on to that onboarding SSID and using iTunes for music. and we can, if we wanted to, change the policy for that device. Now, maybe we want to send a message to the user and say, please see the IT department ASAP, and actually block the user from accessing the network with that device. Or if we want to be a little bit less drastic, we can create a group policy. And in this case, Oakland Unified hasn't created groups, but they can go to the group policies page and say create a layer 7 traffic shaping rule. Why don't we go ahead and do that just to show you what it would be like. And whenever the IT team finds one of these devices, like an iPhone that's using a lot of iTunes traffic, then we can just add a group, call it iTunes throttle iTunes. We can add layer 7 traffic shaping with a custom rule, add a new shaping rule. And here we're going to add, instead of just the whole category of video and music, since we are calling this the iTunes category, we'll just click on iTunes there, and we'll choose a limit and have iTunes traffic be throttled down to 100 kilobits per second. We can also set PCP or DSCP tagging if we want to set it to lowest priority, or if we wanted to take some of these rules, instead of using them to throttle applications, we could take them to prioritize applications. So if we wanted to add another rule, for example, maybe to prioritize VoIP and video conferencing, then instead of moving this slider back and forth, we can have it ignore the limit and not be restricted by the Wi-Fi network. And again, we can set priority tagging, for example, DSCP and PCP tagging as needed. Now we're looking at one particular device. This happens to be an iPhone. We see it's using a lot of iTunes traffic. So we have a great understanding of what this device is doing. We can also go back and see similar information about the whole network and all the devices. In fact, you'll see a pie chart that's very similar to the one that we just saw for the iPhone. This one happens to apply for the whole network. And you'll see a lot of that traffic is going to Google secure traffic. We have some miscellaneous web browsing. We have Google Docs and Google traffic. We have some secure web with an imaging site. We have Google Video. In fact, we can click and expand this out and see over 100 applications that are reported here. And this is also automatically recognized and classified just like the client devices are. In this case, the access points are using deep packet inspection to identify these devices, classify them, and build this report. You'll see some of that traffic that is very natural and is expected, like this Google traffic. We also have some video applications like Netflix, Vimeo, Xfinity TV. We have the music traffic, iTunes, Pandora, Spotify. We have social web, no surprise, Facebook, Instagram, Twitter are all there. And this view and this information is really the basis of making an informed decision about how to control the behavior on the network and the applications that are used, whether they're blocked, throttled, or prioritized. So that's just a quick look at the Oakland Unified School District's networks, and in particular, I wanted to focus in on the Chromebook cart network with the APs installed in the carts, because it's a great example of how they've been enabling Common Core testing, Chromebooks, and carts with secure, reliable, high-density Wi-Fi. So I'd like to, before we go into the products section, I'd like to pause for a moment and see if there are any questions. Notice that Simon has been answering most of those, but I'll see if there are any remaining questions. And a few people have asked about using a Cisco wireless LAN controller for those that have Cisco at corporate and have a wireless LAN controller. The Meraki APs also able to be used with that same controller? And the answer is no, the Meraki APs are managed entirely by the Meraki dashboard, and the Cisco infrastructure and Cisco Wi-Fi APs that you're referring to are managed by the Cisco wireless LAN controller. However, you can use Meraki access points at the branch offices or at the schools, if you have many schools and you have the other Cisco Wi-Fi at a central office or a place like that, and you can manage the Meraki APs through the dashboard remotely and have it deployed at those branches, and they can connect back to the district office or corporate headquarters or data centers in a very similar way to what we saw with Oakland Unified School District. If you already have a data center, perhaps also a redundant data center, you have some data center switching, storage, servers, and so on, all that infrastructure already there. There have been a few questions about VPN and connectivity. Does this work with VPN or tunneled access across network? So yes, the requirement for the Meraki APs is that and there's another related question to internet access. The requirement is that there is internet connectivity available to the access points. In some, not few deployments, I'd say, we've seen that internet access is available, but it is centralized. It's going back through VPN to a headquarters or data center or similar scenario. And yes, that can absolutely work in that scenario. And if the internet connection is intermittent, for example, a remote school might have a satellite connection. We've actually worked with many customers, even outside education, that do have satellite connectivity. If the internet connection is intermittent, that is fine. During those times of lost connectivity, as I mentioned earlier, one wouldn't have access to the live troubleshooting and real-time tools that are built into the dashboard. But if, of course, the internet does come up, then the access points will simply send their statistical information to the Meraki cloud the next time that the satellite connection is restored. And I would just say that if the location is generally one that does not have internet access, in other words, the internet connection is once every few months or something like this, then the Meraki solution wouldn't be the appropriate choice for that type of environment. And someone asked a follow-up question: if the internet is down, do we still have we have access to a local resource on the LAN? Absolutely, the LAN is still completely available. And Brent asks how much bandwidth is used by APs communicating to the cloud, and the average of the connection between the access points and the cloud is around 1 kilobit per second. So it's a pretty low overhead connection. And David asks, when I log in, what am I logging into? Is it the AP? Is it some other box? Is it Cisco servers, the cloud? And David, I assume you're referring to logging into the dashboard, which I did at the beginning of the demo. You're logging into a web-based application. That application is hosted on Cisco Meraki servers in a data center. We have data centers distributed around the world, and that is your interface to monitoring and managing the network. Of course, those data centers and those servers are also connected to the individual APs, but the advantage really comes in that you don't have to log into each AP or each switch. You simply log into that web-based application. Okay, we've had a few questions on products as well coming in just in the last few moments. So I'm going to go ahead and go over the overall product portfolio and lineup. And even though we've been focused on Wi-Fi today, we do have a complete set of networking solutions that are really designed to bring the cloud and those benefits that we've talked about to K-12 networks. Wi-Fi APs are the Meraki MR family. We have Ethernet switches at the access and aggregation layer, layer 2, layer 3, and so on. Those are the MS switches. Security appliances, you can also think of these as Unified Threat Management or UTM devices. These are the Meraki MX security appliances. And finally, our cloud-based MDM, which I briefly mentioned earlier, is called Systems Manager. Now, the Meraki wireless APs are available in a few models, including indoor and outdoor models. We've talked a lot about the MR34, which is the highest performance 802.11ac capable access point. We do have some other access points, including some value-priced ones. And they include actually everything that we showed in the dashboard. Someone asked about the licensing and the product structure a moment ago, and it's quite straightforward. There's one license available for the wireless access points, and you simply buy as many licenses as you have access points. So if you have 300 APs like Oakland USD has, then you'll buy 300 enterprise Wi-Fi licenses. And that includes all the features that we talked about that Oakland USD is using, what we showed in the dashboard, the feature highlights that you see here, things like guest routing, BYOD, traffic shaping, application control, and so on. And the indoor APs have a lifetime warranty. The outdoor APs have a 1-year warranty. We also have telephone and email-based support, all included in that combination of access point plus license. The MR34 in particular is designed for future-proofing Wi-Fi networks and K-12 networks. It does support the high speeds of 802.11ac, including application QoS controls that we showed. It includes a dedicated security radio for security and RF optimization, and it's really designed for cloud management. So it has all the features that we showed in the dashboard, even though we were clicking mostly to see MR34s. All that we just talked about is absolutely available in the MR34 as well. The MX security appliances are available in 6 models to scale from small schools all the way up to very large campuses. They're designed as a complete networking and security solution in a single device, hence you can think of them as a UTM appliance. And they include things like intrusion detection and intrusion prevention. That's based on SourceFire technology, Google Safe Search, YouTube for schools and YouTube EDU, and content filtering that all together enable safe and secure learning environments. The MS switches are available in access and aggregation models. These are in layer 2 and layer 3, and you can see from the photo there in 8-port, 24, and 48-port models. And there are PoE and non-PoE versions available. And as you can see, the switches on the top are access layer switches with copper Ethernet connections, and the ones on the bottom are aggregation switches with full SFP plus connectivity. And just like with the wireless APs, there's a single license that includes all of the tools that are built into the dashboard. We didn't really go into a lot of the details about switches. They do include the same layer 7 application visibility and the client fingerprinting. For the PoE models, they support PoE and PoE Plus, available from any of the ports. We do have high power PoE budget switches with redundant power supplies and fans, and they are enterprise class, built for long lifetimes and high reliability. And they all include a lifetime warranty, including the power supplies and fans. And finally, Systems Manager is a cloud-based mobile device management solution. It manages iOS, Android, Mac, and PC devices or Windows devices. And it's based entirely in the cloud, so it's a little bit different from the rest of the Meraki portfolio in that there's no hardware installed, but it's very similar in the sense that it is based entirely in the dashboard, and all the management is done in the dashboard. So you can use this to secure devices, to push out content and applications, to extend network connectivity, things like Wi-Fi and VPN settings. You can even deploy content through a feature called Backpack, which allows you to push out content to end user devices. And it doesn't require any Cisco infrastructure or Cisco Meraki infrastructure to work. In fact, if you have another networking solution and infrastructure in place, you can still take advantage of MDM with Systems Manager. It's also free. You can sign up by going to that URL below and actually start right away by filling out a short form and see what it's like to manage devices through the cloud and use the dashboard. If you are interested in getting your hands on some Meraki gear, whether it's Wi-Fi or switch or security appliance, we do have a free evaluation program, and we definitely encourage you to take advantage of that and talk to your Meraki rep about it. We'll send Meraki gear to your school. You can set it up and see how it works for you. It's very quick to get up and running. If you have any questions about integration with your existing solution, perhaps you have a similar scenario to Oakland USD with a Cisco infrastructure in the data center and redundant data center, we're happy to help you with any technical integration or configuration questions at no additional cost. And then you can see if it's the right fit for you. If it is, you can purchase it. If it's not, you can simply send it back to us. Okay, we are almost out of time. I've noticed that Simon has been typing away at a lot of these questions, so I'm going to just see if there are any remaining ones that are coming in from the audience. A few people have asked, do we need to use any of the Meraki, any of this Meraki product to use that other Meraki product? For example, do we need to use any of the MX devices to use APs, or do we need to use Cisco routers or switches to use the Cisco Meraki access points? So the answer is no. You can buy a Meraki Wi-Fi solution and use it with any switching and security infrastructure you have, whether it's from Cisco or from another vendor. Similarly, you can buy a Meraki switch or Meraki security appliance. If you already have other Wi-Fi infrastructure, that's fine too. They are all standards-based and designed to interoperate and be compatible with other network infrastructure. A few people have asked about licensing. Does the license need to be renewed yearly? No, it does not. The licenses are available in 1 year, but also 3, 5, 7, and 10-year terms. A few people have asked about getting a copy of this webinar. So we are recording the webinar, and we will make the content available at on our website, meraki.com/webinars. If you scroll to the bottom of that page, you'll see a list of archived recorded webinars. You can click to watch the video and to download the slides from those. Of course, after this event ends, we'll upload this event to that page. Okay, unfortunately, we are out of time. We're hitting the top of the hour now, so we're going to have to wrap it up. But I do want to thank everyone for attending and for your great questions and participation. Thanks to Simon for answering all those questions. And I hope all of you have a fantastic day, and we hope to work with you soon. Thanks, and bye-bye.